Okay, first we want to just see how to take derivatives of an expression like ae to the lambda t. Naturally, we should be able to do this, but we want to be sure. So y prime means dy dt in this case. T is the variable. So y prime is found by the chain rule very simply to be a lambda e to the lambda t, and there are the steps. Y double prime is found to be lambda squared, ae to the lambda t, and here are the steps. We take the derivative of the y prime. A lambda is a constant, so we factor that out, and we have the derivative e to the lambda t, which is just lambda e to the lambda t, giving us this. So, our equation, y double prime plus 5y prime plus 6y equals 0, becomes what? Okay, well, it becomes lambda squared a e to the lambda t, because that's what y prime is, double prime, and then 5 times your expression for y prime, and then 6 times your expression for y, and that's equal to 0. And then if we simply divide out ae to the lambda t, which we should immediately notice is a common factor, we get this equation called the characteristic equation. And this equation has solutions lambda equals 1 and lambda equals -6. You can always find the solutions to this equation. Okay, in this case it's easy to factor the equation, but you can always find the solutions using the quadratic formula. Now, when you do, sometimes there's no guarantee that you're going to get two real values or even two different values, so we have to deal with that. You might get complex values. We can interpret ae to the lambda t for any real or complex value. And if they're repeated values, well, there's a slight complication with that that we'll deal with later. So now we have two solutions, which we'll call y1 equals ae to the lambda 1t, and letting lambda 1 equal 1, that's ae to the lambda t. So we could say, okay, we got solutions, lambda equals this, lambda equals this, lambda 1 will be this solution, lambda 2 will be this solution. So here's our y1 of t, which is ae to the lambda 1t, ae to the t. y2 then would be ae to the -6t. The determinant, y1, y2, y1 prime, y2 prime, is clearly this, and is clearly this, is clearly this, and this is not identically equal to 0. And this tells us that our two solutions are linearly independent. So when we form a linear combination of our linearly independent solutions, that's going to be a linear combination of y equals an ae to the lambda t and a y equals ae to the ae to the t, and y equals ae to the -6t. Of course, these constants will in general be different, so we're going to call them a1 and a2. Then we take the condition y of 0 equals 0 and the condition y prime of 1 equals 1, and we apply these conditions and see if we can evaluate a1 and a2.